Welcome back, everyone, to theCUBE's live coverage here at the New York Stock Exchange floor. I'm John Furrier, host of theCUBE. We're here as part of the CUBE and the NYSE Wire. It's an open community of experts coming together in a trust network, sharing their ideas, knowledge on the top content, more importantly, engaging with the data. That's crucial, critical for the community. We got focus on robotics, AI leaders, large-scale supercomputing's here, and of course, quantum is a big part of it. Our next guest is Pete Shadbolt, co-founder and chief scientific officer of PsiQuantum. From out of the lab and into the fab. I love that phrase. Pete, thanks for coming on theCUBE. We're about to close down the option trading here. Wild day on Wall Street. Wild days in tech, for sure. Thanks for coming on.
John, I really appreciate you having us on, and especially on a day like today. But yeah, hopefully we can talk about something positive and exciting. Yeah, happy to talk to you.
The quantum computing, obviously, you see that and you go, okay, it's a game changer for sure. And everyone kind of loves it here in tech. We see it.
Yeah.
However, there's been rapid, significant advancements in the field. Commercial interest is high. And so there's a lot of engineering going on. And of course, there's also fear, breaking crypto and all these things and all my Bitcoin. And then you got the recent events this past year, Jensen Huang at CES saying, oh, it's like 20 years away, it's never going to happen. Then you got folks like saying, hey, quantum readiness is a big thing that's going on, get ready for quantum. And then CEO of IBM is like, no, it's coming faster than you think. So where are we on all this? Break it down for us. What's your perspective?
Yeah, so I, first of all, really appreciate you having us on and for making it. Time. I'm British. I moved here to Silicon Valley 8 years ago to start this company. When I arrived here, very serious technical people told me that I would never see self-driving cars in my lifetime. Self-driving car fantasy, pipe dream, always 5 years away, and they'll get to 80%, they'll get to 90%, but you'll never actually see a real thing. And of course now, if I go up the street to San Francisco, every other car that I see is a Waymo. I think quantum computing has the same kind of dynamics. It is a technology that has a reputation for being a science project that's always 5 years away. Jensen's comments I thought were very well placed in that he put his finger on the root of the problem, which is that you need about 1 million qubits relative to the 100 qubits that we see in the current system. So Google and IBM, for instance, are both in that regime of about 100 qubits. What Jensen said was that that's 100,000x scale up, right? Like we need a 100,000x scale up. That sounds like a multi-decade exercise. And at GTC a couple of weeks ago, I was lucky to be able to put it to him directly that he himself, of course, has the counterpoint. The XAI Colossus supercomputer, that's a 100,000 GPU cluster, was famously built in 112 days. And the miracle that enabled them to do that is the semiconductor industry. It's the $1 trillion in 50 years that puts 1 billion transistors in your pocket. And our mission, the lab to fab mission, has been to get leverage of that capability and deploy it to make commercially useful quantum computers much faster than anyone has expected them. Yeah.
Pete, that's exactly a great point. I love that whole conventional wisdom kind of diss. It's totally true. I mean, you know what you don't know, but people think they know what they don't know. We don't know. If you look at Jensen's keynote too, he was also spent a ton of time on scale out and scale up. And he spent, I think, 20 minutes of a very valuable keynote on these concepts. And then he then showed the progression of his chipset. So we're already seeing the silicon advantage. All right. So I guess my question to you is, as you get the wafers and get all that stuff on the silicon side, do all the materials management, how does quantum translate into commercial viability with silicon? And is that the main focus, or is it software around it, et cetera? Because NVIDIA had that same path, right? They had to do the software, they buy get the InfiniBand from Mellanox, and boom, they got a system. So it could be that quick. So what's your vision on the accelerated quantum keynote that you'll do when you're like the NVIDIA status of quantum? I mean, accelerated quantum is actually a great name, but is it accelerating, and what happens? What happens next?
So we of course, Jensen and various other leaders from Silicon Valley, from the semiconductor space, these people are heroes for me, for my co-founders, and it's just been astonishing to see the journey that that industry has been on, that those people have been on, and the way that the semiconductor industry has been able to drive growth and just move at an astonishingly fast pace
Yeah.
from small toy systems to now these enormous, unbelievably powerful machines that people are building today. I think obviously I would imagine that there's a lot of people in your building there thinking a lot about growth
Hmm.
today. And one of the striking things about the semiconductor industry is that there is a limit to growth. We're coming to the end of Moore's law. People are starting to resort to frighteningly extreme measures to continue to build more powerful computers, turning on 3 Mile Island, building nuclear power stations to run these systems. And what's exciting for me in quantum computing specifically is that we're going to unlock a categorically new type of computer that is actually going to be at the beginning of that growth curve rather than the end of it. And so the first computers that we build are going to look really primitive. They're going to be powerful. They're going to solve uh, extremely lucrative problems that we won't solve with any conventional supercomputer. But we're going to look back on those systems in 10 years or 20 years, the same way we look back on an IBM mainframe today as a very primitive and early stage technology. But our approach to building even
Yeah.
those first systems is to leverage the highest maturity
Yeah.
fabs. We build thousands of wafers of quantum chips right now in the production line of Global Foundries in upstate New York. It's pretty cool that that's a US based fab where we're doing that.
Yeah.
And that's essentially the highest level of maturity of chip manufacturing that exists on planet Earth. We're very proud of that as a startup company, that we've been able to take a technology that is normally thought of as a science experiment, research experiment, whatever, and put that into a fab shoulder to shoulder with chips for laptops, cell phones, cars, defense,
Yeah.
etc. And we really think that that is the key to getting to millions of qubits and unlocking these profound applications.
What a great accomplishment. Congratulations to you and the team there. One, just as a side note, the first first Apple computer was a wooden box, right? So to put it in
100%.
perspective, right?
100%.
Like, okay, don't judge a quantum book by its cover. I love that perspective. Now, if you go to what you got now, you got production going on. Okay,
Yeah.
so talk about how you see the evolution. You got a little beachhead. You're gonna have commercial products. Are you guys looking at this as a stage kind of execution platform where you have, okay, let's get some chips out there. It may not do it all. It's got a limited qubits, not the million, but that's the roadmap. What is the use case design around the chip? Are there other components? Because the key to all this AI game we're seeing is it's about what's around the chips, right? So you're seeing systems as the new revolution. I mean, that
Yeah.
kind of coming back from the '90s when I was and breaking into business in the '80s and '90s. So everything's about systems. You mentioned mainframe. So there's got to be a theory and vision around how you see the progression of the chip, its relationship with other systems. Can you take us through that vision?
Yeah. So the unpopular reality, like the awkward reality, is that there really is a bare minimum. There really is a bar that you have to exceed, and that's about 1 million qubits. Below about 1 million qubits, I can actually simulate the quantum computer with a conventional supercomputer. And so those systems are commercially useless above about 1 million qubits. And these are approximate statements, but have remained consistent for about 20 years. Above about 1 million qubits, then I start to be able to solve problems that we will never solve using any conventional supercomputer that we could ever build. So there's really a very robust 0 to 1 kind of nature. And again, I'd say this is like self-driving cars. Self-driving cars, there was no minimum viable product. They had to get above a certain level of safety and scale and so on before those things actually started to be compelling. And we've tried to be very realistic about that. We're absolutely building a system. It's a supercomputer-like machine. On that point, I'll say again, when I arrived in Silicon Valley 8 years
Yeah.
ago, a lot of people told me, never say supercomputer, never say high performance compute. It's very unsexy,
Yeah, yeah,
very unfashionable. Everyone's doing apps, whatever.
yeah,
In that time, of course, Nvidia has gone from a gaming company to an H100 company to now a position where
yeah,
their main product is supercomputers.
yeah,
Essentially, scientific computing is the main revenue source of the most valuable company on the planet. It's a pretty
yeah,
extraordinary
yeah,
journey in 10 years.
yeah.
But yeah, that's absolutely what we're doing. And we're very, very focused exclusively on the big machines. We're
Yeah.
not interested in the small machines.
Well, it's just great anecdote there about good advice. Don't listen to other
Yeah.
people who have not been in the trenches. I mean, high performance computing was an old kind of way. It's like, very niche market, but
Yeah.
democratization happened. What Jensen took advantage of,
Yes.
like he said, was just the North Star vision, software, hardware, gaming, then crypto. A
Yep.
lot of those crypto companies are now geo neo clouds, right? So,
Yep.
so why they just were in the arena iterating. So again, this is the advice is don't listen to anyone, just keep doing it, right? If you believe it,
Well, the trick,
keep
I
doing
think
it, right?
there are two tricks that I like. One of them is to forget all of the good advice that I didn't f follow and only remember the bad advice that I ignored. And then the other thing is which I think is a huge piece of why we're in this giant AI wave
Yeah,
today. Where did this AI wave come from? It came from leveraging quite unexpectedly unrelated hardware, right? Gaming
yeah,
GPUs really were the key. Our approach to building a quantum computer is to leverage the silicon photonics technology that was developed for
yeah,
optical interconnects for conventional data centers,
yeah,
cloud computing, and so
yeah,
on. And it's only because that photonics technology is mature enough
yeah.
and that GF could make it that we can actually leverage that to build our machines.
Yeah, and
Without that, we would have to be inventing from scratch and we'd have no hope.
yeah, and that's the great thing about community and ecosystem. I mean, photonics on
100%.
silicon is huge. That changes the game on density, but
Yep.
also talk about the software stack involved because if you look at the old compiler days, you'd have the vertically integrated proprietary tech stack from everything,
Yeah.
right? Now, I mean, who cares if it's in a hardened top, right? I mean, it's on a chip. I
Yep.
mean, if it goes fast and no one needs to really tinker with it, that's great. You can have a homogeneous system that's contained for certain speeds and feeds. Now,
Yeah.
heterogeneous kicks in when you start thinking, open source or software layers or whatever programmability. So, how do you guys view that? Because you're going to be building these systems, and I guess the question is where's your 0 to 1 moment? What's the one?
Yeah.
What is your? How do you define that 0 to 1? Because if you're not hitting a million qubits,
Yeah. So it's a great question, John. It's very thoughtful. I think what I'd say is it's not a chat GPT moment. That's a lazy thing to say. Chat GPT moment for quantum computing. You're not going to have a chat GPT
yeah,
moment for quantum computing. And that's because the chat GPT moment was about mass adoption. It was about
yeah,
millions and millions of people around the world directly interfacing with this thing and realizing that
yeah,
it was compelling. I think that the interesting observation for me is that if you think about so many of our legendary companies and the companies that I would expect to be resilient, especially in uncertain times like those where we find ourselves, TSMC, ASML, SpaceX, Nvidia, I would cite Waymo, these companies, uh, sorry, TSMC, ASML, SpaceX, and Nvidia, like the products of these companies are surprisingly not at all about mass market adoption, right? Like the number of people who actually use an ASML EUV machine, the number of people who actually do a tape out at TSMC, the number of people who design a payload for a SpaceX rocket, that's a tiny, tiny, hundreds or thousands of people. It's the second or third order products of that that end up changing people's lives. The Starlink or um, the chips that we have in our cell phones or whatever. And quantum computing is the same. It's
yeah,
not about mass adoption. This is a very extreme, unreproducible capability that we believe is going
yeah,
to be profound for car
yeah,
companies, materials companies, energy companies, pharmaceutical companies who want to innovate at an accelerated pace. But it's just not the kind of technology where you directly use it
yeah.
in your everyday life.
You
One
know,
day, I hope that people will use drugs, fuels, materials that wouldn't exist without a quantum computer. And I'll be perfectly happy if they don't even know that that thing was designed on a quantum computer.
Yeah, there's the element of like a cloud computing kind of evolution. I mean, Amazon Web
100%.
Services
Yeah,
was misunderstood for a long, long time. In fact, Andy Jassy, who I've interviewed many times, now CEO of
yeah,
Amazon, told me many times privately and publicly on theCUBE, you know, if you have a North Star and you have a vision and a mission, you don't need to explain yourself, but you have to be prepared to be misunderstood for a long time. So I,
100%.
I think you're on that. But I do want to say there's a tipping point somewhere. Like the
Yes,
ChatGPT moment happened before the ChatGPT moment when
that's
people said, holy shit,
exactly.
this deep learning is amazing. And then the community changed. So that there was a
That's
tipping point and then the evolution, right? Like a slow roll.
That's that I couldn't put it better. Like Jensen, of course, was selling GPU clusters quietly, well before everyone got excited about AI.
Yeah,
And I'm perfectly happy for PsiQuantum to be doing similar things
yeah,
without us being plastered all over the newspapers and being on
yeah,
the tip of everyone's
yeah,
tongue.
yeah.
I'm perfectly happy for us to be one of those kind of
You
companies.
know, after living in Silicon Valley for 25 years and still there, and with the studio there and here, but I come back and forth. I study all the CEOs. I meet all of them, most of them, if not all of them, all the best ones. But I've been studying Jensen, and I have a theory. I'd love to get your reaction. I think he's playing with a made hand, right? He's counting cards because if you look at all of his announcement and some of the hyperbole and the mojo, it's as if he's gaming everybody because he's got the supply chain, okay, $250 billion supply. This is just today. Last year I saw his keynote, I'm like, wow, you know, he's basically making moves before he knows what the outcome is. So he's a little bit, you know, in way ahead of everyone lagging in this video game of life, right? So I think, you know, it's clear that, I mean, he's confident. And so all his talks, you know, there's not a lot of, I mean, there's some Jensen kind of fluff in there, but it's not fluff. It's like real, right? So he takes everything he says kind of happen. It's almost as if he's playing with a made hand. What's your reaction to that? Do you think he's got the made hand? He knows it, and no one else
I,
does.
I think that again, think about those companies: NVIDIA, TSMC, ASML, SpaceX, Waymo. These companies are legendary because they operate on a landscape of extreme technical difficulty, and they were the few organizations who managed to survive on that landscape. And if you're a CEO like Jensen or myself, I of course spend a lot of time communicating the company. It's easy to be confident. It's easy to be uh, to 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 speak about the company and to define plans for the company when you already have accomplished so many things
Yeah,
that skeptics said you wouldn't do.
yeah,
We put superconductors into a commercial semiconductor foundry. We put new tools on the shop floor at GF. We developed high power cryogenics. You know, it makes my job really
yeah,
easy. And
yeah,
and of course, what happens is that these organizations compound
yeah,
on that advantage. And you got to stay very active and
yeah,
beady-eyed and attentive.
yeah,
But if you do so,
yeah,
you can compound on that advantage
yeah,
and build these kind of organizations that can just
yeah,
bulldoze ahead. And that's what you see, I think, with NVIDIA. Uh, they they know what they've got, and the onus on them is to continue
yeah,
to uh, exceed expectations,
yeah.
and it's going to be bloody difficult.
They work
But
hard, and they work
yeah,
hard, and
they
they
work
work
hard.
hard, and they stay true to their mission. You know,
Yeah,
it's the confidence and being a little bit cocky is not a bad thing. If you're arrogant, that's where you lose the game. I want to ask you a few questions. Look at NVIDIA and what you guys are doing. One of the keys to success is kind of who's around you, right, in the game,
yeah,
right? If you
yeah,
look at NVIDIA, a lot of things came together. Like I said, I saw Kevin Deerling there. He used to be the CEO of Mellanox. They did $1 billion in revenue,
yeah,
but they had InfiniBand, which, by the way, they only had they had all the customers. There was no more
yeah,
market, so it's either Intel or Nvidia is going to buy them, right? So okay, you know, they were a customer of ours. I got to know them very well, but you think about what InfiniBand did for Nvidia at that moment. It connects things in a way. Now they got some Ethernet with Spectrum X and whatnot. So again, evolution. But things happen. You talk about photonics. So the
yeah.
question, Pete, is what's going on around you guys that's notable that you're excited about that brings the propensity for discovery, the propensity for innovation, where it's
Yeah.
moving fast, and so you need to rely on fellow travelers, right, to invent cool shit.
Yeah. Yeah. So I guess, our entire thesis is based on leveraging the miracles that are worked on a daily basis by the semiconductor industry.
Hmm.
And we are extraordinarily lucky to be able to use the global foundries fab, and to be able to use the broader might of the packaging, OSAT,
Yeah,
contract manufacturing, etc., ecosystem that has been built up around the semiconductor industry. We hire a ton of semiconductor people. We work with an enormously complex supply chain here in the US and elsewhere, and we wouldn't have a hope in hell of building a quantum computer without that. We've also um, been very gratified to have spent time with various of these legends of the semiconductor industry. Um, Jensen, Lip-Bu, Pat Gelsinger is now spending time with us, and I'm personally super grateful
yeah,
to have gotten the time with these guys. And then at a higher level, we recently announced a $1 billion deal, Australian deal with the Australian government, where we're building our first system outside of Brisbane, and a $500 million campus in Chicago. So we're getting an amazing level of support for what is an extreme project here.
yeah,
And the only other thing I'd say there is, because our requirements are so demanding, because um, we have to perform beyond the state of the art of the photonics industry.
yeah,
We have made photonic components that are beyond state of the art. And actually, we're starting to get quite a lot of interest from people who do optical switching, who do transceivers, wanting to look at the things that we've been forced to do
yeah,
out of necessity. And that's pretty exciting
yeah,
position to be in.
yeah. I love the whole point about technical challenge, because you just stay on that and keep it going. That's where the
Yeah,
rewards are, and there's also scale involved, right? Talk about differentiation.
exactly.
Competitive strategy at scale is a whole nother level of kind of new MBA discussions for the classroom, if there's still MBA classes are out there. But that is business model transformations happening. We're seeing already here in robotics, like
Yeah,
the physical and digital convergence. Okay, I mean that's a hardware software integration. Again, open source brings more goodness in, right? So, as people work around the world, this is key. Now, I want to ask you. Well, we have one limited time left. There's a little bit of time left. You mentioned out of the lab and into the fab. I love that line. But you also said before you came on camera, out of the research, academic to lab to
yes.
fab. So quantum has been grounded in academics.
Yep.
Rightfully so, because there's a lot of theory there, right? So it's been out of the academic and into the lab for what, maybe about a decade,
Yep.
so to speak. All right, now fast forward past 3 years. I mean, I remember Amazon wasn't even doing anything with quantum until 4 years ago, right?
Mhm.
So past 4 or 5 years has really been kicked up into how do we commercialize this? So how do you explain to the folks that are still in academia, get out of there, or stay there and do something, be your role here, stay in your lane, contribute to the
Yeah.
lab? What does the value chain look like if you had to kind of break down the swim lanes between role of academic, role of lab, and now also you guys are pioneering this commercial push acceleration
Yeah.
into the fab?
I'd say again, they're very strong parallels. It's a great question. Very strong parallels with what happened in AI. With AI, of course, you can't have a good AI company, AI startup, without some of the most elite, mathematically oriented, academically rooted people that you can imagine, right? Like PhDs
Yeah,
who would normally be in a research group in a university. You must have those people in your company. We're no different. We've got
yeah,
lots of those kind of people here. I think that where the space has been slow to move is really on the hardware. It's experimentalists like me
yeah,
who come from a background of tinkering in a research lab, and there's a very unfortunate temptation to continue to tinker, to continue to do interesting and impressive demos. And PsiQuantum has always pursued a strategy that is best described as extreme, in that we always were completely impatient to get away from that, to get into a commercial foundry, to figure out how we could manufacture at scale, and to do anything it took to
Yeah,
get away from the research lab. And,
yeah.
we're occasionally accused of arrogance or of being
No, it's called
deranged
being a
or
rebel.
whatever.
You got to get to the fab. I mean, come on,
And
that's the game starts there. It's the arena you want to be in.
yeah, and all I can say is that that has served us very well, right? Like that taking those risks, that avoiding too much incrementalism, uh, after a lot of blood, sweat, and tears, 8 years of work and hundreds of millions of dollars spent, we now can manufacture all of the components that we need beyond the state of the art. We've still got a lot of hard work to do, but to me, like I'm so glad that we invested our resources, our time that way. And I mean, I think the only thing that I would, to your question, that I would want to convey to my academic colleagues or to the industry more widely is that I would love if I could transplant some of my self-confidence into those
Yeah,
teams, right? Like self-confidence comes with risks,
yeah,
but insecurity comes with even more profound risks.
yeah.
And that's underreported in my opinion.
Yeah, well, we'll certainly amplify the enthusiasm and confidence because you guys have made a major breakthrough getting into the fab. Again, that's just the arena. Welcome to the game. Now you got to kind of get the next leg of the journey, right? Which is
Yeah,
how do you bring along the ecosystem, your smartest friends and other collaborators, and you really
100%.
kind of there's still more breakthroughs to have, and we really appreciate you taking the time. We'll do another one certainly in Palo Alto. We have a
Oh, I'd
studio
love
there.
that.
You come down. We'll do a full deep dive. But really appreciate your time, and I know you're
This
busy.
has been a joy, John. I really appreciate you guys having us on, especially on a crazy day like today. And I hope that you
Yeah,
get some rest. And
yeah.
absolute pleasure speaking to you.
Cheers. Thank you very
Catch
much.
us anytime. Consider us a neighbor.
Okay. Okay, this is
Cheers.
theCUBE here on the New York Stock Exchange. I'm John Furrier, your host. This is theCUBE and the NYC Wired. It's an open community of leaders. It's a trust network that's building through collaboration and contribution of knowledge and information and sharing, an open marketplace of ideas. This is where the future breakthroughs are coming from collaboration, people on the fellow traveler road together. This is where it's all happening, certainly on theCUBE and the NYC Wired. Thanks for watching.